Hello everyone and welcome to Module 3 about science and progress. In this module, we'll explore how scientific discoveries have influenced literature and English authors, sometimes inspiring hope and sometimes raising deep fears and ethical questions. As always, we'll begin with a brief historical overview. It would be impossible to talk about everything, so we'll focus on the main stages and key moments in the history of science with a special guest. So this lecture won't be delivered by me alone. I'll be joined by my colleague, Professor Abruzzese, our science teacher, who also happens to be very good at English. So enjoy, and Prof. Abruzzese, the stage is yours.
Hi guys! Curiosity has always pushed people to study the world, first through observation of nature and later through experiments and reasoning. Scientific knowledge began in Mesopotamia, where Sumerian priests mapped the sky over 4,000 years ago. They also developed a 60-number system around 3000 BCE, which is why we still divide time into 60 minutes and 60 seconds today. But science as a rational method began in ancient Greece between the 6th and the 5th century BCE. People believed that natural events were caused by angry gods, but in this period, thinkers stopped relying on myths and began to use reason and observation to understand the world. One of the first thinkers to explain nature in a rational way was Thales of Miletus, who predicted a solar eclipse in 585 BCE. Then, Xenophane found seashells on mountain tops and concluded that the land had once been underwater, one of the earliest geological theories. Pythagoras founded a mathematical school in the southern Italy, in Crotone, teaching that numbers rule reality, an idea that still shapes science today. Hippocrates separated medicine from superstition and founded scientific medicine based on observation. Democritus proposed that matter is made of indivisible particles called atoms. Aristotle wrote influential books on physics, biology, and zoology. He observed nature, but he did not perform experiments. He relied only on thought, and many of his conclusions turned out to be wrong. He believed, for example, that heavier objects fall faster than lighter ones, an idea accepted for almost 2000 years until Galileo proved it was false through experimentation in 1600s. In the 3rd century BCE, Aristarchus suggested something revolutionary. The sun, not the earth, is at the center of the universe. This was the first known heliocentric model, but sadly his theory was ignored for almost 2000 years, until Copernicus reproposed the idea in the 16th century. Around the same time, Archimedes discovered the principle of buoyancy by testing a king's crown in water, shouting the legendary Eureka in his bathtub. Eratosthenes calculated the circumference of the Earth using shadows, achieving remarkable accuracy with nothing more than sticks and geometry.
Early science was not just European. In China, scientists invented the compass, the seismograph, even gunpowder. Astronomers catalogued 2,500 stars and studied eclipses. In India, mathematicians developed the number zero, negative numbers, and trigonometry, also the spinning wheel. While China and India focused on discovery and innovation, Roman science focused on applying knowledge to everyday life. Roman science was not about discovering new laws of nature, but about using knowledge to build and improve society. It was applied science, engineering, architecture, medicine, and technology. The Romans built impressive infrastructures such as roads, bridges, and public buildings. These constructions were based on mathematical knowledge and careful observation. And one of the Romans' greatest achievements was the development of advanced water systems, including aqueducts, sewers, and public baths, which improved public health and daily life. The Romans also reformed the calendar. The Julian calendar, introduced under Julius Caesar, was so accurate that it remained in use in Europe until the Renaissance. So while the Romans didn't develop a scientific method like the Greeks, they played a crucial role in preserving, organizing, and applying scientific knowledge. Between the 8th and 13th centuries, Islamic scholars created the scientific center in Baghdad called House of Wisdom. There they translated texts from ancient Greece and India into Arabic and saved them from disappearing. They invented mechanical devices such as the astrolabe. Alchemy flourished and they developed early chemistry techniques like distillation. They invented algebra and algorithms and they wrote fundamental works on optics. So from Greek philosophers to Islamic scholars, early scientists showed the same powerful idea. Observation beats superstition. The universe could be understood.
Between the 16th and the 17th century, Europe experienced a turning point called the Scientific Revolution, a period when scientists completely changed the way they studied nature. In 1543, Andrea Vesalio published De Humani Corporis Fabrica, the first truly accurate anatomical study based on dissection of real human bodies. In the same year, Niccolò Copernico published a book, De Revolutionibus Orbium Celestium, claiming something shocking. The sun, not the earth, is at the center of the universe. This idea challenged church teachings, so Copernico waited until his deathbed to publish it. But once released, the heliocentric model spread fast. Inspired by Copernico, Kepler studied planetary motion and discovered that planets move in elliptical orbits, not perfect circles. Then came one of the most famous scientists of all time, Galileo Galilei. In 1610, using a telescope he built himself, Galileo observed the moons of Jupiter, proving that not everything revolves around the Earth. He also performed experiments with falling objects and rolling balls down slopes, becoming the first to show that experimentation, not authority, should guide science. At the same time, Francis Bacon put into words the foundation of the modern scientific method: observation, hypothesis, experimentation, and measurement. This method still defines how science works today. During this period, scientists also began to organize themselves into scientific communities. In 1660, the Royal Society was founded in London. It became a place where scientists shared experiments, discussed results, and tested ideas together, and it still exists today. Its motto, Nullius in verba, means non fidarti delle parole di nessuno. And it is a clear rejection of authority in favor of evidence and experimentation. In this period, technology pushed discovery forward. Torricelli invented the barometer, revealing the existence of air pressure. Robert Boyle studied gases, and he defined chemical elements. Meanwhile, the microscopic world was being uncovered. Robert Hooke, in his book Micrographia, revealed the complex structures of insects and plant cells for the first time. Van Leeuwenhoek built tiny microscopes and became the first person to see bacteria and other single-celled organisms, which he called animalcules. When he announced his discoveries, the Royal Society sent 3 priests to verify that he wasn't inventing things. Botanist John Ray wrote the first serious classification of plants. In 1687, the scientific revolution reached its peak when Isaac Newton published De Principia, in which he introduced the motion and universal gravitation laws. They governed physics for more than 2 centuries, giving science its most powerful language, mathematics.
After Newton's discoveries in the 18th century, science became increasingly specialized. This period was known as the Enlightenment or the Age of Reason. Researchers focused on understanding how matter, air, fluids, and living organisms really work. Science was no longer seen only as a way to understand nature, but as a tool to improve human life and society. Knowledge had to be useful and accessible. One of the most important features of the Enlightenment was the spread of scientific knowledge. Science moved beyond universities and laboratories and reached a wider public through books, encyclopedias, and public debates. Diderot wrote and edited the Encyclopédie, a vast collection of human knowledge meant to spread scientific and technical learning and free people from ignorance. Nature came to be seen as an ordered system governed by laws that could be tested and measured. Naturalists observed and classified plants, animals, and minerals, making classification a key scientific goal of the century. At the same time, new discoveries challenged traditional religion. James Hutton introduced the idea of deep time, showing that the Earth was far older than previously believed. In chemistry, Antoine Lavoisier and Joseph Priestley identified oxygen, helping to establish modern chemistry. Literature and philosophy reflected this shift, celebrating reason, curiosity, and discovery. Around 1760, the Industrial Revolution began in Britain. New machines changed the way goods were produced, making production faster and more efficient. The most important invention was the steam engine, improved by James Watt, which powered factories, mines, and transport. And technology transformed daily life. Cities grew rapidly, workers faced harsh conditions, and nature was controlled and exploited. So progress became visible and sometimes frightening. In 1859, the English biologist and naturalist Charles Darwin published On the Origin of Species, introducing a theory that would completely change science, evolution through natural selection. For the first time, biology provided a scientific explanation for change, adaptation, and diversity in living organisms. According to Darwin, species are not fixed or created in a final form. Instead, they evolve gradually over time, adapting to their environment. This revolutionary idea transformed the way humans understood life, nature, and their own place in the world. A few years later, in 1869, the Russian chemist Mendeleev developed the periodic table, showing that chemical elements follow clear patterns and precise laws. This discovery reinforced the belief that science could explain reality through order, logic, and rational systems.
After Darwin, scientific discoveries accelerate dramatically. Biology, chemistry, and physics developed powerful new theories from genetics to the periodic table. Life was explained through chemistry, and invisible phenomena such as radiation and X-rays were discovered. Science became increasingly specialized and interconnected. By the end of the 19th century, scientific progress was no longer seen as purely positive. While science has improved technology and industry, it also raised new doubts and fears. Some discoveries challenged traditional belief and created a crisis of certainty. Darwin questioned humanity's place in creation. Industrialization showed the dark side of progress. Science appeared powerful, but not always controllable. Relativity and quantum mechanics challenged classical idea of space, time, and matter. Science no longer offers simple certainties, but complex and sometimes disturbing explanations. As a result, confidence in absolute truth and progress began to weaken. At the same time, new scientific fields such as psychology began to question the idea of fully rational and stable human mind.
Literature reacted with fascination and terror. This is the era of the Gothic and Romantic novels, where stories explored scientists crossing moral boundaries, dangerous experiments, creations escaping human control. And this brings us directly to some of the works you will study, starting with Mary Shelley's Frankenstein, published in 1818 and considered the first true science fiction novel. Many thanks to Prof. Abruzzese for joining me in this lesson and for making science and literature meet.
Thank you, and bye bye.